In 2025, inside a quiet laboratory at London's Natural History Museum, scientists unwrapped a fossil so small it could fit in the palm of your hand. The bones were fragile, no thicker than pencils, but their story was enormous. They belonged to a new species, Enigmacursor mollyborthwickae, a small herbivorous dinosaur that lived over 125 million years ago in what is now North America. While the world usually celebrates colossal predators and towering sauropods, this discovery proved that true survival often belonged to the unnoticed. Its name, Enigmacursor, means enigmatic runner, a creature shrouded in mystery but built for speed and intelligence. Unlike most famous dinosaurs, this one was small, quick, and likely relied on strategy rather than strength. Yet, in the fossil record, such delicate animals almost never survive. Somehow, this tiny dinosaur defied both time and the odds, and in doing so, it's forcing scientists to rethink everything we know about life during the Early Cretaceous. To understand the world of Enigmacursor, picture the Early Cretaceous around 125 million years ago. North America was not yet the continent we know. It was a patchwork of rivers, ferns, and low coastal plains under a warm, humid sky. Towering predators like Acrocanthosaurus roamed the region, and herds of massive sauropods left tracks in the mud. Among these giants, smaller dinosaurs darted through underbrush, quick, nervous, and alert. Enigmacursor lived in this tense world where one wrong step meant becoming prey. But instead of brute force, it thrived through agility and awareness. Fossilized bone structure shows long hind limbs, light musculature, and a flexible tail for balance, signs of an animal designed for speed. It may have foraged in open clearings at dawn, vanishing into ferns at the first tremor of a predator's step. Its survival depended on staying unseen and outsmarting everything bigger around it, a tiny shadow among monsters. The story began when paleontologist Dr. Susanna Maidment and her team unearthed a small skeleton from a red sandstone layer once thought too fragmentary to yield much. For months, the fossil sat in storage until modern scanning technology revealed the truth it was nearly complete. Unlike many small dinosaurs found in China's Liaoning beds, this one came from North America, filling a crucial gap in the record. The team named it Enigmacursor mollyborthwickae, honoring both its puzzling nature and the donor who funded its research. Using micro-CT scans, scientists reconstructed its internal bones, revealing hollow limb cavities and fused ankle joints adapted for running. The skull, though tiny, showed large eye sockets, evidence of keen sight, possibly for dawn or dusk activity. The discovery was formally published in 2025, immediately drawing attention for its completeness and for challenging the idea that only giants define the dinosaur age. Every feature of Enigmacursor's body tells a story of adaptation. It stood barely 1 meter long and weighed less than a household cat, yet it possessed proportionally longer legs than most herbivorous dinosaurs. Its tail was rigid toward the base, but flexible at the tip, helping maintain balance during fast turns. The lightweight skeleton, with air-filled bones, resembled that of early birds, perhaps a sign that this lineage was edging closer to avian traits. Its small beak-like snout indicates it clipped soft vegetation ferns, cycads, or young shoots near the forest floor. Unlike heavy-bodied plant eaters that chewed endlessly, Enigmacursor likely nibbled quickly and moved on, minimizing time spent in the open. Its intelligence also stood out. The skull shape and enlarged brain cavity suggest strong sensory awareness, particularly vision and coordination. Everything about this dinosaur whispered efficiency, not power. In an ecosystem dominated by giants, Enigmacursor thrived because it refused to play by their rules. When paleontologists name a new species, the name often reflects its anatomy or discovery site. But Enigmacursor was different. It was named for its mystery. The bones were almost too perfect, preserved in positions suggesting a rapid burial event. There were no teeth marks, no predator damage, no scavenging. How did such a fragile skeleton survive whole in sediments that usually crush or scatter remains? Some scientists think it was trapped in a sudden flood or collapsed riverbank, quickly entombed in mud before decay began. Others propose that its delicate bones fossilized inside a natural protective layer, such as a burrow or hollow log. Even its classification was puzzling. It shares traits with ornithopods, hypsilophodontids, and basal neornithischians, but doesn't quite fit any known group. It's a mosaic, a bridge between lineages, showing that evolution's boundaries were not as clean as textbooks imply. That's why Enigmacursor, the running riddle, fits perfectly. The discovery of Enigmacursor shines a light on an often overlooked truth. Most dinosaurs were not giants. For every T, Rex, or Brachiosaurus, there were dozens of smaller species, filling ecological roles much like birds, rodents, and reptiles do today. These small dinosaurs were the glue of prehistoric ecosystems, seed dispersers, scavengers, and prey for larger hunters. But because their bones were fragile, they rarely fossilized, leaving gaping holes in our understanding. Enigmacursor changes that. Its near-perfect preservation gives scientists a new model for how these small herbivores lived. It suggests they traveled in groups, relying on numbers and speed for safety. It may even have built small nests or burrows. In short, this fossil proves that life's survival during the Cretaceous depended as much on quick thinkers as on colossal beasts. Evolution doesn't always favor size, it often rewards adaptability. If Enigmacursor had been discovered 20 years earlier, it might still be sitting unrecognized in a drawer. What changed everything was technology. Micro-CT scanning, 3D reconstruction, and synchrotron imaging allowed paleontologists to examine internal bone structures without breaking the specimen. This revealed fine details, blood vessel channels, bone density gradients, and muscle attachment points invisible to the naked eye. Digital mapping let scientists simulate how the dinosaur moved, showing that it could sprint faster, relative to its size, than most animals of its era. Even microscopic analysis of sediment around the bones identified plant pollen and spores, giving a snapshot of its environment: lush vegetation, soft ground, and freshwater pools. Technology didn't just find Enigmacursor, it resurrected it virtually, turning data into motion. For the first time, we can visualize a tiny dinosaur weaving between ferns, heart racing, eyes bright, vanishing into ancient green shadows. To survive among apex predators, Enigmacursor needed brains as much as speed. Its enlarged optic lobes suggest strong visual processing, possibly for detecting movement. Its long limbs and stiff tail made it capable of sudden bursts and sharp turns like a prehistoric antelope. Scientists theorize that Enigmacursor may have used group tactics, several individuals feeding in open areas while others kept watch. When threatened, they'd scatter, confusing predators who relied on single targets. Fossil trackways of small herbivores from similar strata support this behavior. Some prints show sudden direction changes in unison, like synchronized flight responses. This intelligence-driven survival contrasts sharply with the brute strategies of larger dinosaurs. In a world of claws and teeth, Enigmacursor's weapon was awareness. Its story echoes a timeless theme: Survival doesn't belong only to the strongest, but to the smartest, the fastest, and the unseen. Paleontology often glorifies the giants because they leave the biggest fossils. But Enigmacursor reminds us that the smallest creatures shape the ecosystem's rhythm. They were the ones recycling vegetation, spreading seeds, and feeding predators. Remove them, and the entire system collapses. In that sense, Enigmacursor is a symbol of balance, the quiet architect behind the scenes. It also offers clues to evolution's continuity. The lineage of small, fast, bipedal herbivores likely gave rise to later forms that survived the extinction event by evolving into modern birds. Every sparrow that darts through a garden carries a trace of that same nimble heritage. Enigmacursor didn't just survive its giants, it outlived them through its descendants. In that way, its small skeleton casts a shadow longer than any T-Rex fossil, one measured not in size, but in legacy. Enigmacursor mollyborthwickae may never adorn movie posters or headline theme parks, but its importance is profound. It shows that dinosaurs were not simply monsters locked in endless combat, but participants in a complex, delicate web of life. Through fossils like this, we glimpse the true fabric of prehistory, fast, fragile, and full of surprises. Its discovery bridges continents, connects ancient behavior to modern biology, and challenges us to value the overlooked. In every era, greatness often hides in smallness. The fossil's perfection, its mystery, and its message converge on a simple truth. Evolution's success is measured not by might, but by adaptability. Enigmacursor, the little runner that outsmarted giants, reminds us that even in a world ruled by titans, intelligence, speed, and subtlety could still win the day. And sometimes, the quietest footprints tell the loudest stories.